Good morning, everybody. So today's topic, very interesting and very important topic. I am going to deliver OSI reference model and TCP/IP model. Of course, I divided this into two parts. So part A and part B, or part 1 or part 2. So today I am going to discuss the first part 1 or maybe part A. So in this, what is the layering in networked computing? We know the layers basically divided into 3 parts: OSI model, TCP/IP model, and protocols at each layer. And basically, we are discussing the layering in networked computing through OSI model, TCP/IP model, protocols at each layer. Okay. What are the learning outcomes in the understanding the need of layering in networked computing? Understand the need of layering in networked computing. It is why we are calling it as a networked computing, because all the computers are connected in a network. The process which may be done, whatever the process done through this in networked computing is layer by layer basis. What is the need of layering in networked computing environment? And that understand the OSI model and TCP/IP. So I told you in the beginning that this is divided into 2 parts, part 1 and part 2, or part A and part B. So we will discuss something today and the other things tomorrow. Function of protocols and their role at each layer: TCP protocol, UDP protocol. Understanding the role of header in communication between layers. So you can able to know when we are going ahead, what is the header and what are the different layers and all. Of course, you may have already some knowledge on layers, what are different layers. So we will see. How the data sent from one host arrived to the target host. Okay. Breaks down the communication into smaller and simpler parts. breaks down the communication into smaller and simpler parts. Breaks down the communication into smaller and smaller, like dividing it into parts. What is it called? It is modular approach. It is a modular approach. Why a layered model? Why a layered model? Why do we need a layered model? Why do we need layered model? Layered model. Easier to teach communication process. It is very easy to teach the communication process. Speeds development. Speeds of the development. Changes in one layer does not affect how the other layer works. Okay. Standardization across manufacturers. Yesterday, at the previous class, so I explained the various network standards. So at each and every layer, these should be standardized. These should be standardized. Allows different hardware and software to work together. Reduces complexity. Why a layered model? Why you go for the layered model? Easier to teach communication process. Speeds of the development. Changes in one layer does not affect how the other level works. Standardization across manufacturers. Different hardware and software to work together. It allows different hardware and software to work together. Reduces complexity. So there are three models we mentioned. That is, the first one is the OSI reference model. What is the OSI model? Open Systems Interconnection. Open System Interconnection. This model was first introduced in 1984 by the ISO, International standard organization. International standard organization. International standard organization. Outlines what needs to be done to send data from one computer to other. It outlines what needs to be done to send data from one computer to another. Not how it should be done. What needs to be done to send data from one to other, but not how it should be done. Protocol stacks handle how data is prepared for transmission, to be transmitted. In this model, the specification needed are contained in seven different layers that interact with each other. So what is the OSI model? Open System Interconnection. It was introduced in 1984 by the International Organization for Standardization. It outlines what needs to be done to send data from one computer to another, not how it should be done. How it should be done will be taken care by protocol stacks. Okay? The specification needed for OSI model are contained in 7 different layers that interact with each other. 7 different layers that interact with each other. So model. What is the model? What is the model? This is commonly referred to as the OSI reference model. The OSI reference model. So what is the OSI model, reference model? It is a theoretical blueprint that helps us understand how data gets from one user computer to another. Okay? What it tells, it is a theoretical blueprint that helps us understand how data gets from one user computer to another user computer. It is also a model that helps develop standards so that all of our hardware and software talks nicely to each other. So, In the previous class I told you the standards are very, very important. So what does this model do? This model helps to develop the standards so that all of our hardware and software talks nicely to each other. It aids standardization of networking technologies by providing an organized structure for hardware and software developers to follow to ensure the products are compatible with current and future technologies. How the standards to be, how the methods to be developed, or standards to be developed. It aids standardization of network technologies by providing an organized structure for hardware and software to developer to follow to ensure these products are compatible with current and future technologies. Isn't it? How the model should be? The model should be used for today's technology, and it should be useful for the tomorrow's technology. The tomorrow technology should not be, future technology should not be started from the again from the zero state. Whatever the things we have developed, that should be useful for the next step. So that's what the model says. What should be the model? The model is to be like that. Okay. The 7-layer model. 7-layer OSI model. In OSI model, there are 7 layers. Already told you that there are 7 layers in the OSI model. 7 layers in the OSI model. Why use a reference model? Why you are calling it the OSI reference model? Why? See, it serves as an outline of rules for how protocols can be used to allow communication between computers. It serves as an outline of rules. It will give some outline for computers to communicate each other. What is that called? Those are protocols. So for the protocol, this should be a outline. Okay. Each layer has its own function. Each layer has its own function and provides support to other layers. Provide support to other layers. So why use a reference model? This serves as an outline of rules for the protocols, how they can be used to allow communication between one computer to other. So there are OSI model mentioned that there are 7 layers. So there are 7 layers. Each layer has its own function. Not only it does its function. It also gives support to the other layers. This is, in a nutshell, we are defined the OS 7 layers OSA model and its functions. Now, what are the other models, reference models are in use? The most well-known one was TCP/IP reference model. So later we will compare the why you go for the TCP/IP and what is the comparison between the OSA and TCP/IP model. What is that necessity? As computing requirements increased, the network modeling had to evolve to meet ever increasing demands of larger networks and multiple vendors. There are so many vendors. The computing network requirements increased. So there are so many networks are okay. In each network, subnetwork, there are so many. So the network modeling has to evolve, increase. It should evolve to meet the increasing demands. Okay. Not only the same vendor network, there may be different vendor networks. So all these to keep it in mind, the network modeling has to evolve all these requirements. Problems and technology advances also added to the demands for changes in network modeling. Say, day by day, the technology is advancing. The network has to adapt to these changes. Whenever there is a technology advancement, there are problems also. All these problems also added for the changes in network model. Okay. Why the 7-layer OSI model? It is a reference model. It should be a reference for the protocol to allow the communication between the computers. There are 7 layers. Each layer has its own function and provides support to the other layers. But to seek for the other alternative like other reference model, I need what they should bear. What are the different requirements? And the reference model is in such a way that it should evolve, the model is to be evolved to meet the ever increasing demands of larger networks, multiple vendors, problem and technology advancements to the demands of advancements also added to the demands for changes in network model. Okay. We'll see the evolution of 7-layer model, 7 layers. Single layer model, first communication between computer device. This is single layer, only one layer. hardware and software, device A and device B. The communication is between these two. This is a bidirectional, maybe from this side to this side or this side to this side. Dedicated copper wire or radio link. This is a link. There may be direct connection between these two through copper wire or radio waves, through radio waves. And hardware and software inextricably intertwined, and single specification for all aspects of communication. Single aspects for all aspects of communication. See, that is single layer. It is two layer now. Application layer, application technical standards. Problem. Applications were being developed to run over ever increasing number of media or signaling systems. Okay. What is the solution? Separate the application aspects from technical, that is signaling and routing aspects. This application layer concerned with the user interface, file access and file transfer. File access and file transfer. Okay. Next, 4-layer model. Network connectivity inherently requires travel over the intermediate devices. Travel over the intermediate devices. Application, network, data link, physical layer. Technical standards level divided into, see here in the back side we have given an application layer and technical standards for 2-layer model. These technical standard level is divided into network, data link and physical layers. Okay. See, physical layer. So what these other three functions? That physical, bottom one, physical layer describes physical aspects of the networks. Cords, wires, etc. Cords, wires, etc. It specifies interconnect topologies and devices. So everything we have discussed regarding these topologies and devices. The physical layer, it describes the physical aspects of the network. What are the physical aspects? Cords, wires, etc. It also specifies interconnect topologies and devices. What are the different topologies? We have studied star topology, mesh topology, bus topology, and so on and so forth. Hybrid topologies on devices. What are the different hardware devices we have studied? Where hub, router, NAC, so many devices. Okay. How these physical devices can be interconnected? The network layer. Now we go for the network layer. In the network layer, it defines a standard method for operating between nodes. In the network, a standard method for operating between nodes. An address scheme is defined. An address scheme is defined. It accounts for varying topologies. Okay. Physical data link network application. Physical data network layer. Now data link layer. It works with network layer to translate this logical IP address into hardware addresses MAC for transmission. Okay. This IP address is a logical address. This logical address is converted into hardware address, MAC address for transmission. It defines a single link protocol for transfer between nodes. It requires single layer, single link protocol for transfer between evolution of 7 layers. Fourth. So already we have seen the up to 4 layer. Now 5th layer, one more layer added, that is transport layer. 5 layer model, which increases the quality of service, QoS. Variable levels of data integrity in network. Additional data exchanges to ensure connectivity over worst conditions became the transport layer. The transport layer. What does the purpose of transport layer? Quality of service. Increases the quality of service, data integrity, data exchanges. Okay. Six layer model. 6 layer model. Dialog control and dialog separation, means of synchronizing transfer of data packets, allows for checkpoint to see if data arrives at node and end state became the, what is the new layer? Session layer. Session layer. So what is the purpose of it? Dialog control and dialog separation. Synchronizing between the data packets arrived and reached. There should be a checkpoint that the data is arrived to the stations or nodes. That will be done through session layer. The final. What is the new one? Presentation. Okay. The 7-layer OSI model, addition of management and security. Addition of management and security. Standardizing notation for or syntax for application messages. Set of encoding rules. It is data transfer syntax. Became the presentation layer. Okay. So what is the purpose of this presentation layer? Standardizing notation or syntax for application messages. Addition of management and security. Set of encoding rules. Transfer syntax. So for all these came the presentation layer. So what are the 7 layers? Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application. What each layer does? It's a superficial. So, physical layer. What the physical layer? Binary transmission. Here, the wires, connectors, voltages, data rates, these are all comes into data link layer. Access to media. How the data will be transmitted from one system to other media. Transmission media. Network. Which network? Address and path. Address and path. The network. Transport. End-to-end connection. Session. Inter-host communication. Presentation, the data presentation. Network processes to applications. The application layer does. See, application layer. Network processes to applications. applications. It provides network services to application processes such as email, file transfer, and terminal emulation. See, these are the different applications. Gives end user applications access to network resources. It gives the end user applications. End user application. What is the application of all these? Say email or file transfer. Okay, gives end user applications access to network resources. Where is it on my computer? Workstation or server service in MS Windows. In MS Windows. See? Next, presentation layer. What does the presentation layer presents? Data representation. I told you. This data ensure data is readable by receiving system. Format of data. Data structures. Data transfer syntax. Okay, data transfer syntax. Data transfer syntax. Session layer. Session. Inter-host communication. Establishment. Managing termination of session between the two applications. If I am talking with somebody, this session, sometime that's a session, there will be a connection. These applications allows the applications to maintain an ongoing session, to maintain ongoing session. Where is it on my computer? Where is it? Workstation and server service. Windows client for NetWare. Windows client for NetWare. This is a session layer. Next, transport layer. Transportation. End-to-end connections. Concerned with transportation issues between hosts, data transport reliability, establishing the connection, terminating the connection, maintaining the connection of virtual circuits. Provides reliable data delivery. Reliable data delivery. TCP in TCP IP, that we will see in the next sessions. Receives information from upper layers and segments it into packets. the information received will be segmented into packets. If there is any error, that error correction can be done on detection. Error correction and detection can be done. Okay. The main transport layer is responsible for delivery of message from one process to another. One process to another. See here. From network layer to transport layer, or from session layer to transport layer, or transport layer to session layer. Huh? So there is in between there is a communication between session to transport or transport to network. Two transport are from transport. See, from transport layer data header, it's a packet. It's a transmitting to, see, in the what we are seeing here, that the next one, the transport layer. We are talking about the transport layer. The transport layer is responsible for delivery of a message from one process to another. Say here the transport layer to session or session to transport, isn't it? Say here that from session layer. After session layer, what is the layer? Transport layer. Next, network layer. So, from session layer through transport layer, the data will be segmented here. 1, 2, 3, like that. The segmented here. The segmented data will be to network layer. Will be to network layer. From the session layer through transport layer to network layer through data segments. Now the data will be through data segmentation. Through data segmentation. Okay. Data segmentation. See other reverse process from network layer to session layer. And so reverse. The data can be this way or the reverse way. So network layer. It provides network wide addressing and a mechanism to move packets between networks. It provides a network wide addressing and mechanism to move packets between networks. That is routing. It is responsible for network addressing, routing, okay. Internet protocol from TCP IP routing. It provides the network wide addressing and mechanism to move packets between different networks. It gives the address and best path. The best path is routing. Addressing, network addressing. See here again. Network to data link or network to transport. So from transport layer through network layer to data link. This is one process. The reverse process from data link layer to transport layer. Okay. data packet through network layer. So what is happening in the network layer is responsible for delivery of individual packet from the source to host or host to the destination to host. Host to destination or destination to source to packets from the source host to destination host. That's simple. Source to destination. Okay. Network addresses. What it addresses? Network wide addresses used to transfer data across subnets. Used by routers for packet forwarding. Used data by routers for packet forwarding. Example, IP addresses. Where is it on my computer? This is on TCP/IP software. Say data link layer. What are the applications of data link layer? Places data and retrieves it from the physical layer and provides error correction and detection capability. Okay. Again, it gives the data to network, it links the data to network or from the network to physical layer. Again, from network layer, data will be linked to headers and again to physical layer. The data link layer is responsible for moving frames from one node to the next node. So from data link layer to from physical layer to data link layer to network layer, like that. The frame is at the end. Here the frame is before this T2. Sublayers of data link layer. MAC, Media Access Control, gives data to the NIC. Control access to the media through CSMA or CD. Is already we have seen in the network standards. And logical link layer manages the data link interface or services access points. Can detect some transmission errors using a cyclic redundancy check. If the packet is bad, LLC will request the sender to resend the particular packet, that is the CRC. The last one, physical layer. It determines the specifications for all physical components. That is cabling, interconnection methods, data encoding, electrical properties. These are the physical properties. So these are what are the standards? Ethernet, token ring, wireless. Okay. So how the data? Physical layer. So the transmission media from the data link layer through physical layer through transmission media to another system. See, one system to other, or one host to node, host to source, host to destination node. The physical layer is responsible from the movement of individual bits from one hop to the next. What are the What are the physical layer components on the computer? Network interface card, unique 12 character hexadecimal number permanently bound into the manufacturer. Cablings, twisted pair, fiber optic, coaxial cable. So these are available in the for reference to the protocol. All these available in this websites.